I'm going to use stargazer to show the results in a beautiful way for us to be able to analyze it. I install stargazer. I use the library command to invoke it. Okay. Once I'm done with that, I will now type stargazer and I'll type my first model. The first model was gene multi. Do you remember? It was an OLS model. Now, I haven't done the GLS. I'll remove the GLS and the physical GLS from here. Okay. So, and then I'll remove this one too from here. So I'm going to now do that. And another one is gene multi log linear. Do you remember we had the log linear model? Okay. And then we have a situation where all of them, we took the log of all of them. Fantastic. And then we have the robust standard error, okay, model. That one. That's it here. Okay. The robust standard. Now I need to give names to them. So after writing gene multi, I need to tell the reader that this is the OLS one. So at this section, I'll call that one OLS. Okay. So I'm calling that one OLS. Okay. The next one, so this is where you label names. Okay. I'm adding the names to it. If you can do this, this is really, really good. This is what you see in journal articles. Then you have gene multi log linear. So this is the one where the dependent variable was logged. You remember, K was logged. And by the way, they are all up here. Okay. Log linear. The dependent variable was logged. Let me just show you here. Just so that you can view it. This is it. Okay. Log linear. So you can see that in this one, K was logged, nothing was logged again. So that model, I have it here. I'm going to add it. I'm going to add that model to our model. So that is log linear. And so on the right hand section here, okay, on this right hand section, I call it log linear model. That's the name I gave to it. The next one is all of them were logged. All of them were logged. So that one, I call it log. Okay, so there's one called log log. Log log is the one where the price was logged and this one was logged. Let me just go back and go and look for that log log and add that log log. Let me add that log log. Oh, there you go. So that is a log log, both the price and then the quantity demanded were logged. They were the ones that were logged, log log model. So I need to order them nicely. So you have the OLS, the log linear, the log log. I need to write that first. Bring a comma, log log. Then you have gene multi log all. So there's log log and there's log all. So this is log log. I need now log all. There's one called log all. I just want to rename this. Copy. Oops. So I do a comma. I bring a double apostrophe. And then I type log all because you need to let the order follow. You see, there is no comma here, so R is telling me that I need to add a comma. So you do a comma, and then the last one is the robust newer west. Okay, newer west standard error. I want to give it a simple name. Okay, I want to call it robust standard error. Okay. Just call it robust standard error. And then once I'm done with that, I indicate that I want the type to be text, and I should keep certain things. These are certain things I should keep. I'll tell you about them later. So some of them is I want him to tell me the sample size. So this is n. Tell the stargazer to give you the sample size, to give you the R square, to give you the F statistic, to give you the log likelihood, that is the LL here. To give you the Akaike information, the BIC, the log ratio, the word test, and several things. Okay. When you read a little bit about stargazer, it will tell you all of this. So I'm going to run this command, and then we expect a very nice result. Wow, fantastic. This is it. So see the table. This is a beautiful table that you are seeing. And the stargazer will actually label it the way you want it. So you can see that sometimes you see tables, they will talk about table 1, table 2, table 3, and all of that. Model 1, model 2, model 3, that's it. So you can see that the first one is the OLS. It is continuously reminding you that this is the OLS. That's the first one. And kill is the dependent variable. That's model 1. And the star here means that the price is significant. You can see that the what do you call it? The intercept is not shown. Okay, the intercept is not shown. Now that first model, the log of P wasn't used. So you can see that this section here is empty for that first model. The second one, the log of P wasn't used. It was just the kill that was logged. Okay, and that one you can see that the price is even more significant. Okay, you can see that there. And then the log, this is where all of them, sorry, this is where only the P was used, was logged. Okay, and that one is what you see there. And then the all log is not only this, you can see the C wasn't logged, M wasn't logged, but we have log C and log M. Okay, so we took the log of all. Okay, and you can see that in that one, the log M was not significant, but then, and of course, in the normal OLS, the M wasn't significant. But in the log linear, the M is significant. And in the log, M is significant. Okay. And then finally, the robust. You see, the robust is giving it another name also. Because I called it robust standard error. And he's telling you that that is for the coefficient test. Oh, beautiful, guys. This is superlatively good. So on the basis of this, you can now indicate and see clearly which model is giving you. Let me finish. Take your time and let me finish. This is just good. This is good. It's good. It's good. You just need to understand what's happening before you appreciate why I'm so happy. And by the way, when you go down, the stargazer is beautiful. Okay, and by the way, when you go down, look at the first model, log urban. Okay, the location wasn't significant, but in these ones, in the log model, and then so the one we just logged the dependent variable, and the one we logged both the dependent variable and the independent variable. Okay, you can see that location is what? Significant. Location is significant, but we indicated that, however, the coefficient changed. You can see the coefficient changed. Okay. The coefficient have changed. That makes it a little bit questionable. Okay. So it's good, but then the coefficient is changing. So we will not have better information to tell. And then you have the one that is log all. Okay. Look at the log all. The log all to the coefficient change. So all these three models, where you took the log, you took the log. All of those that you took the log, the coefficient changed. And now finally look at the newer West, the robust standard error. The coefficient didn't change, but it was still significant compared to the original OLS. And it was significant all through. And when you come down, by the way, guys, you are going to see the beautiful results for all of them. The constant is brought at the bottom. It's not really normally the most important thing. So the constant is at the bottom there. And it tells you, the model tells you the observation number that you have. It tells you the R square. It tells you the F statistic. Okay, and all of that. Now, the R square was not given for the newer West. And the reason why the R square is not given for the newer West is because the newer West doesn't change anything except the standard error. So the R square will still be this very R square. I indicated other things. By the way, the p-values will be significant at 1%, at 5%, and then at 0.1%. So those are the p-values that have been shown there. I indicated the log likelihood, the word ratio. Those are not important for these models. So obviously, R is sensible enough not to bring them into that. But when we start doing the weighted least square, the feasible GLS, the GLS and all of that, they will be brought there because they use those ones in their computation. So guys, I want to ask you, on the basis of this, which model do you think that it is much robust, and now our results will be spoken of? Now let me tell you, there is no question that the robust standard error is the best. It tells you that a 1 unit increase in the price of gin would decrease the quantity demanded of gin by 3.15 units, and this is significant. This is significant. Okay. It also tells you that a 1 unit increase in the complement price of gin will reduce the quantity demanded of gin by 0.10 or 11 units. Okay, and that's significant because complement price means that it's moving. It also tells you that income, that a 1 unit increase in the price of gin will reduce, 1 unit increase in the income of the average income of the people will reduce the quantity demanded of gin bitters by 0.99. So what this means is that when your income should go up, you will no longer be buying this gin, because to you, gin is a normal good. And yes, it is an, what do you call it? Let me see. To you, gin is an inferior good. Sorry, it's not a normal good, it's an inferior good. A normal good is a good where when your income rises, you buy more of that good. But an inferior good is a good when you, so when the person's income rises, the person will not use that increase in income to go and buy gin bitters, akweteshi again. He will rather go and buy whiskey. Whiskey, top class brandy. Because to them, now his level of income has gone up, so he will switch to buying a better income. And so this good, this gin bitters is an inferior good, and so you buy less of that. That's why you have a negative sign. And then, if you go to interpret the others, okay, log urban. If you see log urban, it means that, okay, quantity demanded is expected to be 5.11 units less if the people are in an urban area than in a rural area, which makes sense. Because if you're in an urban area, you will like to take what? Better drinks than if you were in a rural area. So if you're in a rural area, you will take more of the gin bitters. But if you're in an urban, you take whiskey and those things. Occupation teaching. Okay, what it means is that if your quantity demanded is expected to be 19.43 units less, okay, the demand for the gin will be less if the people are teachers than if they are fishers. That's what it means. And it's true. If the people are teachers, they are more likely to be much more, highly intellectual. So they are unlikely to go for the gin bitters. And occupation trading to the same thing. Okay, they will reduce it. Okay, quantity demanded will be less by 46.47 units. Okay, if the people are traders than if they are fishers. So the people who are traders are likely not to go for much more than if they were fishers. And if you look at religion, if you are a Christian, you will go for more of the quantity demanded. So quantity demanded is expected to be 15.56 unit more positive, significantly more if the people are Christians than the reference category, and the reference category was Buddhist. So if the people are Christians, they are more likely to go for alcoholic gin bitters, burukutu gin bitters, than if they were Buddhist. And the same way, if they were Christians, as Muslims, if they were Muslims, quantity demanded of the gin bitters is expected to be 23 units less. So the Muslims they don't go for much of the quantity demanded less than if they were Buddhist. Okay. So ladies and gentlemen, this helps you, and all of them are significant. This helps you now to explain. Stargazer helps you to put the thing in a beautiful analysis, and you are going to now make an incredible move in this work. That brings us to the end of the entire caboodle of putting results that are determined to solve heteroscedasticity, putting it all together, both the transformation and then the Hiba-West and the other one together in a stargazer to be able to make sense of the results. Next time, we are going to look at the final way of dealing with heteroscedasticity. That is the GLS, generalized least square, feasible generalized least square, weighted least square.